All right, good evening, everyone. So, this is the lecture for your lab tomorrow, and it's pertaining to the gravimetric analysis of hard water. So first of all, let's talk about what hard water is. Now, there's a table that's in your lab handout that references to how you classify what hard water is, and so hard water is just where you have various minerals that are dissolved into it. The more minerals you have, the more harder that water is going to be. And so our focus today is going to be to determine how hard the water is that we have in our lab. So to do this, what we're going to have to do is we're going to have to isolate the ions that are present. Now, in our case, we've spiked it with some calcium, and so spiking it just means that we're isolating. We know what mineral, what element is present. So the way we're going to do this is we're going to take calcium and we're going to react it with sodium carbonate. Now, in the chemical reaction conversation that you're going to be talking about later this week, you'll be learning about this is a double replacement reaction, and that whenever you react the calcium and the carbonate, it's going to form a precipitate, which in this case is the calcium carbonate. Now, the rest of these that you're looking at, these are all aqueous, and they're just part of the solution. Aqueous just means that it's dissolved into solution. But the solid here, what will happen is that it will precipitate out to the bottom. Now, the term gravimetric analysis is where we use gravity to help filtrate this precipitate out. So you can imagine it in the beaker that you're looking at, you have a layer of solid on the bottom. And so what you're going to do is you're going to set up another beaker, and in that beaker you're going to have a funnel. All right, these are found up on the top shelf, and in that funnel you're going to have some filter paper. All right, so this filter paper that you see, the way you get it prepared is you fold it in half one way, and then you fold it in half another way, the other way, opposite. And then you grab a leading edge and you open it up. It'll look exactly like the shape of the funnel. Now, what you would do is you're going to pour out the solution and the precipitate into the filter paper, not going over the edge of the filter paper. So what's going to be in the bottom is the solution, and what's going to be trapped inside the filter paper will be the calcium carbonate. And so what we'll do then is you'll place that filter paper onto a watch glass, and you're going to put it in the oven. You're going to heat it. So we're going to heat it in the oven for 30 minutes straight. All right. You're then going to cool down and measure the mass. All right. Now, once you've done that, you'll write it down. So then you'll heat it for 15 minutes more. All right. And then again, you'll cool down and measure the mass. Now, the objective here is to pay attention to the mass. Now, if the mass doesn't change very much, and I would say in order of a thousandths, like 0.001, then you know that you are dried out. But if it's changed quite significantly, then you'd want to put it back in the oven just for a few more minutes. But 45 minutes should be plenty for that. Now, what you'll do is you'll take this mass. Now, keep in mind that you need to make sure you measure the mass of the filter paper before you do anything. So as soon as you get the filter paper from the front, go back to the balance, measure its mass. All right, you've got to have that mass that's dry. So you'll subtract out the mass of the filter paper, and what you'll end up with are the grams of calcium carbonate that you precipitated out. Then we're going to go and do some stoichiometric calculations, and you're going to take the grams of calcium carbonate, you're going to convert that into moles of calcium carbonate. Now, that again, to go from grams to moles, you have to use the molar mass for calcium carbonate. You'll have to look that up on the periodic table. So Secondly, you're going to use the mole ratio. So you have, well, you can see it's pretty straightforward. It's 1 to 1. And that converts us into moles of calcium. And then you're going to, again, use the molar mass for calcium, and you're going to convert that into grams of calcium. Now, paying attention to the table here, we're going to notice that we are going to want our units in milligrams per liter. So the first thing you do is to get the hardness is you have to convert grams into milligrams. All right, that's part of it. That's the first part. The second part is this volume, this liters that's in the denominator here. So knowing the volume of solution used, we can determine the hardness of the water. So again, in the procedure, it tells you how much volume of the hard water you're going to measure out. So make sure that you record that volume that you measure out. Don't just assume that it is, let's say, 20 milliliters. Make sure you measure it with the bottom of the meniscus in the graduate cylinder. Don't just assume, because one of the biggest errors that you're going to find is that people make assumptions. And so you got to make sure you measure. So take that volume that you measure, that's in milliliters, and convert it into liters. And that volume in liters goes here. The milligrams goes on top. Then you divide the two in each other, and you have your answer for the hardness of the water. Now, the question is, how does it match up with what we see in the classification? Is it soft, or is it upwards above the very hard? Now, we know that, I will say this, is that when we drink our tap water here, our tap water is actually pretty good and straight. It doesn't have a whole lot of mineralization. So we oftentimes talk about tap water being soft. And now if it was hard, it'd have a very distinct flavor to it. It wouldn't taste right. And then even in fact, if you boiled it, it would start to form this thick white precipitate on the top where the water boils off. And so that's a good evidence of the water being pretty hard. So we're pretty fortunate. But in the lab, we want to check the hardness of the water. So now you'll do this in groups at your tables, all right? And so each of your tables will be given a number, a group number, all right? So what you'll do is you'll post your group number on the front board, and then all of your data points that you see on the board will be written into this chart here. Now, whether you have 6 groups or not, that's dependent on the size of the class. So now what you'll do is you will determine the average, the mean, average and mean, the same thing, the standard deviation, and then the percent RSD. Make sure you show your calculations so that way you get full credit. So you'll find in the lab manual, I'm not showing all the details from this page, but you'll see in the lab manual, I give you the various equations here for how you calculate mean. You all should know how to calculate the means. If there's 6 groups, all right, add them up, divide by 6. That's what this summation means here. All right, and then for the standard deviation, now standard deviation is how much does it deviate from the mean. That's what you're referring to here. This symbol here, the mu symbol, represents mean, and then the n is the actual value that you that's up in the chart here. So if there are 6 groups, you'll do the subtraction 6 times, all right, and then they all add together. So you'd have n minus mu squared, or plus the next number minus the mean squared. So let's say there's just 2. All right, so that's the summation of this. You're going to divide this by the n minus 1, which if there's 2 values, there's 2 minus 1, that gives you 1. And then everything that's done here is then you're going to take the square root of this. Now, you do not want a large standard deviation, because the large standard deviation means that the group numbers are spread very far apart. What we want are the numbers to be relatively close together. Now that's difficult because each of our groups are doing our own thing, and each group will make an error, and then that shows up in the overall result. Now the percent RSD is where we get to see how good the data actually is. So you'll take the standard deviation that you calculated from here, and you'll divide it by the mean, and then you'll multiply by 100. So the smaller the percent RSD, the better your number is, the better the group data is. The higher that percent RSD, that's not a good thing to be. And so typically on a good day, you'd want your percent RSD to be 10% or less. So we don't know what we're going to do in terms of our group. So we'll just see how that plays out in the very end. Now, again, you'll have to do these calculations, and you'll have to put your information on the board. And so we're going to be here for the entirety of the lab. That's just the way this lab is. So, but make sure that when you come in that you have a good, clear understanding of what we're doing, and make sure you take careful notes of this, obviously, and then we'll go over some of this in the beginning. But the main thing is I want to make sure you guys have plenty of time. So we're going to get started. So either way, you guys have a good night, and I'll see y'all tomorrow in the lab. Thanks for watching.